Well, I'm again here. He's very tired for every day. As I already said this morning, the modern scientific research on the Shroud began only in 1898. Why doesn't go on? Modern scientific research began only in 1898 when the first photographs of it by Secondo Pia revealed the negative characteristics of the image. This gave scholars the possibility to study in detail both the cloth and the image, making the Shroud known all over the world. But it is only in the last 50 years that wide coordinated studies have taken place. There is no doubt that the most important of these more recent studies have been the analyses made directly on the Shroud between October 8 and 13, 1978, for 120 hours by an international team of 44 scientists, the majority of whom were members of STURP. And we are lucky to have here John Jackson, who was the chief of this big and important expedition. Since then, over 30 years had passed. With the exception of the taking of the cloth sample of radiocarbon dating in 1988, and the removal of the patches and the substitution of the Holland cloth in 2002, no other direct interventions on the Shroud have been done. In order to significantly develop the research, it would be opportune to have the possibility to organize new data collection. This data collection must start from the results of the 1978 analysis, and it would give scientists the possibility to have at their disposal new information for making concrete progress in acquiring knowledge about the characteristics of the cloth and of the image. In my report, I will provide a brief description, a brief program of the possible future lines of research. I will divide my proposals into 3 sections corresponding to the main fields of research: the cloth, the double image, and the blood stains. We can start with the analysis of the chemical, physical, and textile structure of the cloth, obviously. Several people have asked for a repetition of the radiocarbon dating of the cloth of the Shroud made in 1988. However, as the late Alan Adler always asserted, this experiment would be significant only after the possible anomalies which might have influenced the 1988 results have been carefully checked. These anomalies have been pointed out by experiments and research conducted in these last 20 years. A detailed analysis of the cloth could be very useful in verifying statements regarding the homogeneity and the representativeness of the sample used for the radiocarbon dating. For example, in order to confirm Raymond Rogers' hypothesis about the anomalous characteristics of the cloth samples used for the radiocarbon dating, it is necessary to analyze in detail the structure of the threads coming both from the main corpus of the shroud and from the zone contiguous to the sample taken. The results of these wide-range analysis, microscopy, spectrophotometry, and so on, must be compared among them and with the results present in literature. It could be useful to obtain precise measurements of the dimensions of the threads and of the flex fibers using not only integrated systems of optical and electron microscopy, but also such new technologies as atomic force microscopy. A further interesting argument to study is the comparison between the so-called side strip and the main corpus of the shroud, included the stitching thread. Although the dimensions of the threads and fibers cannot provide definite answers, they could give indications about whether the two parts are of the same origin. The X-ray fluorescence spectra obtained in 1978 highlighted the presence on the cloth of iron, calcium, and strontium. These data are very important for studying the characteristics of the image and of the blood stains. The theories asserting the pictorial origin of the image should be based on a higher content of iron or other inorganic elements in the image sites. The data obtained by STURP point out no differences in iron content in image and non-image sites. This statement has been criticized by Walter McCrone and other scholars. Their criticisms are substantially based on the statement that the sensitivity of the detection method, the X-ray fluorescence, and of the measuring instrument utilized was not able to detect the very low concentrations used to paint the image. In order to settle this controversy, it is necessary to analyze inorganic elements such as iron, calcium, and strontium with more sensitive instruments than the one used in 1978. It would be suitable to take into account also other detection methods such as laser-induced breakdown spectroscopy, which is useful for the quantitative detection of the metal elements, new mass spectrometry methods like time-of-flight secondary ion mass spectrometry, which is a very sensitive analytical technique for surfaces analysis able to detect both molecular organic species and inorganic compounds, and inductively coupled plasma mass spectrometry, which is a highly sensitive type of mass spectrometry. The use of highly sensitive methodologies could enable science to characterize and hence to distinguish between sites without image, sites with image, and sites with blood stains. These analyses can be done using microsamples, and this is a very important feature. Moreover, it would be useful to repeat some spectroscopic analysis done in 1978, like ultraviolet visible spectroscopy, Fourier transform infrared spectroscopy with microscopic technique, Raman spectroscopy with macroscopic technique, and fluorescence spectroscopy. The limits of the spectroscopic data are often due to the low signal resolution or to the superposition of signals of the typical cellulose signals. Hence, it should be useful to utilize high-resolution instruments. Moreover, it would be opportune to use infrared techniques able to detect only signals coming from the surface layers of the samples, and nuclear magnetic resonance spectroscopy for its huge power in recognizing molecules, in particular organic ones. The only problem with NMR is the significant amount of samples requested, which is of the order of at least some milligrams or more. Hence, only high-resolution instruments could be used, probably only instruments operating at more than 1,000 megahertz. Raymond Rogers deduced the presence of matter, alizarin, or of its aluminum metal complexes since the sample used for the radiocarbon dating when put into water left a yellow material which becomes red after acidification. To verify Rogers' hypothesis, it might be useful to study a microsample of thread using methodologies like high-performance liquid chromatography, mass spectroscopy, high-performance liquid chromatography infrared, or gas chromatography mass spectroscopy. These tests are very delicate due to the tiny dimension of the samples that it is possible to remove. To complete the tests on the cloth, it would be necessary to provide an in-depth map of the pollens on the cloth using the method and techniques of modern palynology in order to obtain a detailed pollen diagram that permits precise, not only qualitative but also quantitative microscopic analysis. In the meantime, it is possible to try to verify the suggested hypothesis of the possible presence of flowers on some sides of the cloth. Moreover, it would be useful to repeat the ultraviolet fluorescence photographs made by Vernon Miller and Samuel Pellicori in order to determine the characteristics of the sites without image, of the site with image, and of the sites with blood stains, of the burn marks, of the water stains, and of the so-called poker holes. The carbon dust and the residual material found under the patches during the conservation work made in 2002, and which has been carefully collected and catalogued, could be studied using microscopic techniques. Ultraviolet and visual spectroscopy, fluorescence, infrared, and Raman spectroscopy with microscopic technique. Researchers must carefully define the success probabilities of this analysis because it is well known that in several cases the collecting and interpretation of spectral data of carbon material is quite hard. Moreover, this analysis could be used to evaluate the hypothesis of a possible influence of the Chambéry fire on the radiocarbon dating. The analysis should be an enzymatic hydrolysis of the cellulose with the examination of the hydrolysis products with the aim to verify the presence of alkylated or carboxylated glucose derivatives. Specific color measurements in well-defined sites contiguous to the burn marks could be very useful. These measurements should be done using precise calibration processes so that it is possible to evaluate possible color variation with time. This could highlight any possible increase in cloth decay. These results could provide important indications for improving the conservation conditions. The edges of the poker holes could be studied using spectroscopic methodologies in order to verify the hypothesis that their origin is not due to combustion. Moreover, it could be opportune to repeat the spectroscopic analysis on the water marks, also using mass spectrometry and measurements of their iron content in order to compare these results with the ones obtained in sites without watermarks and in sites with image. Finally, spectroscopy tests could be done on the Holland cloth and on the patches removed in 2002 in order to compare the characteristics of the cloth sites, both those exposed to air and those that aren't, for studying the aging of the cloth. Now we pass to the second argument, the analysis of the image carried out using various experimental methods. It is obvious that the most important research is to investigate in the deepest possible way the nature of the image, with the aim of trying to clear up its origin and giving objective considerations about the several hypotheses about its formation proposed in the last years: vaporograph, pictorial origin, thermal origin, light origin, oxidation dehydration, electromagnetic radiation, and so on. The most important and detailed data regarding the study of the image were given by the papers of the scientist of STURP and of other scholars after the scientific investigation of 78. The nature of the image is clearly the central argument of research on the shroud. Therefore, it is very important to widen and deepen the acquired knowledge. The fundamental arguments to deepen are the following ones. Now I try to make a very brief summary. The comparison between the iron concentration of the sites with and without image. This research must only be done on sites certainly not contaminated by the presence of blood, because otherwise the iron content would be increased, obviously. The measurement methodology must ensure very high precision, sensitivity, and repeatability. It will be very useful to determine previously in the laboratory, working on control samples, the iron concentration able to give a shroud image like optical density, and then to evaluate its spectroscopic characteristics. Test on the presence of proteins. Also in this case, it is necessary to work on sites certainly not contaminated by the presence of blood, because otherwise proteins are surely present. The chosen methodologies should be able to give an unequivocal answer that is due only to the presence of proteins, and if possible, to determine the type of the source organism. It would be prudent not to exclude the hypothesis that the binder used by the possible forger is of a plant origin, and hence with a polysaccharide structure. In order to confirm the hypothesis of a process of oxidation degradation as the cause of formation of the image as suggested by STURP, it would be important to have data connected to the chemical structure of the molecules responsible for the yellow color of the surface of the flax fibers in the sites with image. Examination of different sites with image in order to point out possible chemical and physical heterogeneities. In particular, it would be opportune to carry out a comparative study of the frontal and dorsal image, so as to highlight possible differences in their characteristic and formation processes. The three-dimensional reconstruction of the frontal image should be extended in detail also to the dorsal image. It would be important to propose a detailed study of the sides of the nose, of the knees, and of the heels, because some scholars assert the finding of traces of aragonite in these sites. It could be interesting to confirm its presence and at the same time to verify the possible presence of aragonite also in other sites of the shroud. To study the various hypotheses on the formation of the image, it would be important to confirm the absence of the image under the blood stains. As you can see, it's a very complex program. And the answers to the above-mentioned problems can be obtained through a systematic comparative study of flex samples treated with the above techniques, iron oxide and proteins for the pictorial hypothesis, thermal treatment of the sample for the thermal origin of the image, and so on. And from, I was saying, a comparative study of flex samples treated with these techniques and the shroud samples with and without image. The methodologies are fundamentally the same as those already described for the study of the sites without image, and I think it's not necessary to repeat. And now we can pass to the third and last type of sites, the analysis of the blood stains. In spite of the large amount of data collected in 78 on the blood stains, several criticisms have been raised about the results obtained. Therefore, it would be necessary to repeat on blood sites the same tests already proposed for the cloth and for the sites with image, in order to point out the presence of substances typical of blood structures and to study them from the point of view of chemistry, physics, biology, and forensic sciences. The fundamental arguments to deepen are the following ones. The detailed documentation of the extraneous material present on the fibers in the blood sites. This study must be done with microscopic images with different enlargements and different techniques: optical microscopy with bright field illumination, dark field illumination, and phase contrast illumination, electron microscopy, AFM, and so on. To check in detail if in this extraneous material there is iron with a higher concentration than in the other shroud sites, and if there are no traces of mercury. In reality, the presence of iron is not contested, but knowledge of its concentration in the blood sites is very interesting. Confirmation of the experimental results given by John Heller and Alan Hadler about the absence of such microelements as manganese, nickel, and other elements that are usually present together in the mineral iron pigments could be very, very important. Likewise, the presence of mercury sulfide should be carefully studied in order to state whether it is accidental, as claimed by Adler, or systematical, as claimed by McCrone. Moreover, it would be useful to check the possible presence of potassium and chlorine ions. In all this research, it is necessary to use methodologies able to check the various elements at a level of microtraces. To check in detail for the presence of proteins, unlike for the sites with the image only, the presence of proteins on the blood sites is not denied, because in the opinion of McCrone and of his supporters, proteins are used in the preparation of temperas in order to thicken them and to carry the iron pigments. However, detection of the presence of proteins, and in particular their characterization, is a fundamental point, and their analysis must be done using both spectroscopic methodologies and mass spectrometry methodologies. The research and characterization of proteins on blood sites is very important, in particular if its results are compared with the results of the same research made on sites with the image only. In fact, the possible detection of proteins on blood sites and the contemporary absence of proteins on the image only sites should have significant diagnostic importance. The data obtained by STURP for the fluorescence spectra of blood sites show the absence of fluorescence, while fluorescence has been detected on the edges of the blood spots. Therefore, it would be advisable to repeat this research. A study strictly connected to the presence of proteins is the detection of systems relevant to human blood, made with the use of methods typical of biology and biochemistry. Working on the blood material taken in 1978, Pierluigi Baima Bollone proved the presence of iron, and using fluorescent antibodies methodologies, the presence of human blood. It would be important to repeat these studies with modern systems using still today antibodies reaction for their specificity. Moreover, it would be useful to verify and carefully document whether the blood present in different sites of the shroud belong to the same man, and if in some sites it is the blood of a living man, and in other sites blood that came out from a corpse. In particular, the borders between the blood and the serum spots should be studied in detail. Finally, it will be useful to verify and repeat the research regarding identification of the blood type. It will be interesting to try the use of detection techniques of blood traces used by police forensic teams. The methodology used for studying the blood stain could be usefully used also for the scourge marks. And now we come to closing comments. First of all, any future research must take into account the research proposal advanced by the STURP scientists at the end of their studies on the data collected on the Shroud in 1978. These proposals were officially presented on October 16, 1984 to Cardinal Anastasio Ballestrero, the papal custodian of the Shroud at that time. Second, it is fundamental and unavoidable to choose very carefully the site to examine. It is absolutely necessary to distinguish very carefully among the various sites without image, with scorches, with burns, with poker holes, with water stains, with image, with blood traces, mixed. Third, in order to avoid too invasive interventions, it is absolutely necessary to use samples of very little dimensions, and hence any taking of samples must be done only with the use of microscopic techniques. Fourth, with the aim of both reducing the number of samples to be taken and of maximizing the information obtained, every sample must be used to make several tests. Therefore, the research must be planned in such a way as to first carry out on each sample all of the non-destructive measurements, and only afterwards the measurement which can modify the nature of the sample. For example, extraction with inert or reactive solvents, the recording of multispectra, and so on. Fifth, before taking any sample from the Shroud, it is necessary to simulate on samples prepared in a laboratory all the measurements and experiments planned on the Shroud in order to verify their feasibility, answer types, utility, and invasiveness. This is a proposal of a big work that is necessary to do on the Shroud in order to collect new data which are essential for the improving of the knowledge of the research. Normally when I say these things, someone asks, but when it will be possible to realize a program of this type? I don't know. I don't know for two big problems. First of all, I'm not the actual Pope. The problem is very big because he is the owner of the Shroud. But I have also a second big problem. The probability that I have very, very little probabilities to become the next Pope. And so I cannot solve the problem. I spoke several times about the necessity of doing new collection of data with the Secretary of States of Vatican, of Holy See. And the problem is very, very well known, but obviously the decision, the final decision about the possible future starting of a program of this type depends exclusively by the owner of the Shroud, which is the Pope. The Pope will be in Turin during the next exposition of the Shroud. The exact date is not yet communicated, but it's sure that it will arrive, and we hope to have the opportunity to speak with him about this problem in order to give him all the data necessary in order that he can do the best decision possible, and is the only answer I can give you. Thank you very much. Please.